let me go over this here so you can follow along. And as I talk, please go and submit your whatever you have, because that lab is going to close in a few minutes. So I'm going to make the tester. I'll make the car. All right, so it says we should start out with fixing the total miles driven. So let's look in the car. And so we need to keep track of the total miles driven. We do that by an instance variable. We always put the instance variables on top. And we should remember to always declare them as private. So here's my instance variable. Now it's a good idea to construct in the constructor to set it. So let's do that. Okay, when I add gas, does that change the miles driven?
No.
Well, I guess I have to drive to the gas station, but that's a different problem. So no. When I drive, that'll change the miles driven. How?
Miles driven plus distance.
Yes. So at this point here, this is a construction that we've seen many, many times. With the bank account, we've seen balance equals balance plus amount. With, what would you do earlier today? Was the balloon? With the balloon, we've seen radius equals radius plus amount. But I could swear we had another class this morning where we saw kind of the same computation. So you take the existing one and then you add a little bit more. Now, some people were still struggling with this, and if you just totally don't really know how to start, my strong suggestion is to come up with a specific scenario. And not exactly a fast eraser here. Okay. So come up with a specific scenario, and it even helps, I find, to make a little table for the values of the instance variables. We only have one instance variable right now, which is miles driven. And now let's say I want to call drive and drive 100 miles. At the beginning, miles driven is 0. And now after I call drive 100, what do I want miles to be? A miles driven? 100. Now I call drive 200. And now what do you want miles driven to be? Right. And now that you know kind of what behavior you want, it becomes much easier to implement it. Because now you say, gosh, how do I get from 100 to 300? Well, obviously all I have to do is add those 200. And then this equation here, the 100 plus the 200 becomes the 300. Then the equation starts making perfect sense. And so it's a standard trick to, if you don't really know what to do this, pick some specific values. Most people are very good at working with specific values because we have an intuition. We know what happens when we drive, and then we drive a little bit more. And many people are not so good with coming up with a math right away. So if you find that you're amongst those people, there's no shame in coming up with a specific scenario and let that guide your thinking. And so just pick any old numbers that look like you can easily manipulate them. And people do that all the time. I do that all the time when I have to do something complicated with tiling some rectangle into smaller rectangles or something. I look at actual specific numbers. I'm not smart enough to figure out the math. and I have a PhD in this stuff. So, and we'll see that in a minute when we go on to the to the computation with the gallons. All right. Okay, now it says run the tester, and you all know what happened. So now we need an instance variable for the amount of gas in the car, because we need to model what's in the gas tank. So gas. Okay, when I buy a car, it is sadly empty. And now when I add more gas to the tank, let's say I add 10 gallons, then I can now play the same game. So I can say, now I have two instance variables, miles driven, and lowercase gas. Instance variables should always be in lowercase. So gas starts out with 0, miles driven starts out with 0. Now I fill 10 gallons into the tank. Okay, does that change the miles driven? No. Does that change the gas? Yes. By how much? 10, right? And now I'll do it again. And add another 10 gallons without driving. Now how much do I have in the tank? 20, right? So now you see it's the exact same logic as we had before. Adding gas is just the same thing as driving miles. So at this point, hopefully, we can use our powers of abstraction and say, well, it's got to be the exact same equation. So that would be gas equals gas plus amount. All right. And now we come on to, get gas in tank. We might as well actually return how much gas we have in the tank. I saw one a group where inside the gas in tank method, they did some kind of a computation. And they tried to figure out how much was driven and all of that. And then they tried to subtract some volume on the fly inside get gas in tank. And that's actually never a good idea. The reason is this is an accessor method. You just use it to measure how much gas is in the tank currently. And an accessor method like that should never change the object. It shouldn't cost you any gas to look up how much gas you have. Okay? Now, it's a common beginner's mistake because you have all of these slots and you don't quite know where to put something. But it's a good rule of thumb that when you have an accessor method like that, it's okay for it to compute a value, like the get volume for the balloon. Computes the value. It takes the radius and turns that into volume. But it doesn't deflate the balloon by just asking how big it is. And so the same thing here. So this is a particularly trivial accessor method. It just returns an instance variable. And so what the important part is no computation here. All right, moving on to now the consumption of the gas. So that's the hardest part, of course. So where does it happen? It should happen inside the drive method. Because as you drive, you consume gas. Now, sadly, that's how automobiles work. Now, I'm sure engineers everywhere are working on improving that sad state of affairs, but right now, that's how they work. We drive, we lose gas. So in all likelihood, here, it's going to have to say gas equals, and then whatever the new gas level is. We don't quite know yet what it is. And so now I gave a little scenario, because this is a problem that I used to just assign as a homework. And I was always stunned to see that 80% of the class could not figure this out. And the reason had nothing to do with object-oriented programming or Java or braces and semicolons. It had to do with that people had a hard time translating the 7th grade algebra into what was required. So let's work through the algebra. And again, the key is to take a specific scenario. I can't overemphasize how important it is to make yourself a specific scenario every time you're stuck. So the specific scenario I had is that the efficiency should be 50 miles per gallon. Why did I choose 50 miles per gallon? Does anyone have a car that has 50 miles per gallon? Sadly no, but it looked like a nice and even number. I could have used 20 miles per gallon. That was my second choice, but I thought, yeah, that sounds kind of embarrassing. So I used that. So we drive 100 miles. How many gallons do we use? 2, right? $50 miles use up 1 gallon, the other 50 miles use up another gallon. And so at this point here, if I'm driving a distance of 100 miles, then I want my gas to go down by 2. Right? So in that case, I would want to say gas equals gas minus 2. All right, but of course it's not always going to be 2. So I have to find a general way of finding out how much gas did I consume. So let's put that computation in here. Okay, so how did I get the 2 out of the 100 and the 50? Yeah, thank you. 100 divided by 50, right? So in general, the 100 is what? It's the distance. And the 50 was the efficiency, right? All right, so that's my gas consumed. And now over here I said gas equals gas minus 2. Well, that only works if I consume 2 gallons. But what's it in general?
Gas minus distance times efficiency.
Okay. Or if I use my nifty new variable.
Gas consumed.
So it would be gas equals gas minus gas